And now we're going to do a confidence interval for a proportion. Now remember, what you'll be doing now in your quizzes is we're talking about different types of data. There was continuous data, or we had talked about continuous random variables, and we also talk about interval or ratio data. And for that we can find the mean. But say if I wanted to know what percentage of students own a car, and the question I would ask is, do you own... Yes? Oh, thank you. Thanks. Okay, so I want to know what percentage of students own a car. The question we're going to ask is, do you own a car? And the answer to that is yes or no. So what type of data is that? It's nominal, okay? It doesn't have a number, it has a name, nominal. So I can't, and what's the mean of yes and no? Well, there is none. So that's why we can't use a mean for that data, because it is nominal data. So what we do instead is we find proportions. So we asked 48 students if they own a car, 15 say no, and 33 say yes. Okay, so that gives us the proportion of car owners in the sample, which is known as P. Now what's really annoying is in next topic, we're going to be talking about a p-value, but this is a different p. Okay, so this p here is to do with proportion, sample proportion. Sorry, I didn't invent it. Anyway, it's 33 over 48, which was 6.6875. Okay, so we can't say that for all students 68.75% of them own cars, because we've only got a sample of size 48. So what we want to do is we give it as a confidence interval. So what we do is we find that we are 95% confident that the proportion of all students, so this is in the population, who own a car lies between 0.56 and 0.82. So different information. One is you're given a number. Now when somebody tells you a number, you mean, well, it can't be exactly 0.68 unless you've asked every single student. And so do you mean 0.68 plus or minus 0.001 or plus or minus 1, or what sort of range of accuracy? And that's what your confidence interval tells you, is how sure can you be? And there's got a lot of, it's quite interesting, this whole thing related to political opinion polls, and I've put some questions in the quizzes for section 6 that'll get you thinking a little bit about how political polls are reported. Okay, so this assumes that the sample we took is representative of all students, because remember we talked yesterday about different types of samples. So to calculate the confidence interval for 1 minus alpha, we use this formula. Okay, so by 1 minus alpha, what we mean for that is for a 95% confidence interval, alpha is 1 minus 0.95, which is 0.05. So alpha is the area that is the amount that isn't inside the confidence interval. Okay, so let's have a look here. So we've got P, which is that proportion we just found there, the sample proportion. Okay, sample proportion. And then we've got remember in the last one we had a theoretical value. What letter was that last time? Do you remember? That was a T last time. Okay, so we used a T distribution in the other one. In this one we're going to use a Z distribution. And we look up Z alpha over 2. Because it's a confidence interval and we want 95% of it to be in here, so 5% is going to be on either side. So how much is going to be on this side? It's going to be 2.5% and 2.5% there. So that's why we go alpha, which was the 0.05, divided by 2. So we look up our Z for that, and I'll give you a table of those in a minute. And then there's this thing here. Now this is the standard error for the proportion, and you don't need to know where it comes from, it's just what it is. So the same as S over root n was the standard error for the mean. This P, 1 minus P over n all square rooted, is the standard error for the proportion. Okay, so that's about all you need to know for that. And now you need to know, and this is a page you will need to print out and keep beside you when you're doing this for your quizzes. And then you'll need to learn how to do it off by heart, because we will give you, this formula will be given to you in the quiz, but you will not be given how to do it in Excel. So you'll have that formula just to remind you, but you will need to be able to create this from memory in the quiz. It's not that bad, promise. Okay, So we have green, we have our inputs is that it's a 95%, our sample size was 48, and our number of successes is 33. So those are the inputs that I gave just back here. So we've got 48, 15, 33. Actually no, 48, 33, and 95. Okay. Then the next bit down here is simply working out what's going to be in the tail. So that's that bit here. So we've got 95, and that's 2.5. So that's 0.025. So that's 1 minus that divided by 2. Okay, our sample proportion, P, is B4 divided by B3, so number of successes divided by the sample size. This thing here is our standard error, so it's that thing there. It's the square root of P times 1 minus P over N. So it's that thing there. Now, the one thing that's hard to see here is there is a negative sign in there. Okay, it's because of the way, remember we did norm-inf? Now, this is not norm-inf, this is norms-inf. Okay, there is an S in here. And the S is because it is the standard distribution. Now, if you don't want to do all of this stuff, you can just put the number in, which is 1.96, and you'll learn those three really quickly. So for 95% confidence interval, this will always be 0.195 blah blah blah. So you can either use this norms-inf thing, or you can just use the number. Okay, our margin of error, that's B9 times B10. This thing here is our margin of error, so it's the Z value times the standard error. Okay, and then we've got our lower bound and our upper bound, so to get that, that's going to be B8, the sample proportion minus it, and that's the sample proportion plus it. Okay, I realise that this is not going to make a lot of sense now, so what you need to do is actually try that out yourself with this in front of you. Just go through step by step, make sure that you can get this one exactly how it is, and then you can try it out. Don't just make one up and replace the numbers in it, because that works fine while you're in the non-proctored quizzes, but you need to actually know how to create that on the spot in the proctored quiz. Okay, so that's how you do your confidence interval of a proportion.